Hi guys, this is your first video for Pre-AP Chemistry Unit 1, and we're going to be talking about matter, substances, and how we distinguish between all the different types, how you can separate the different types, and what a lot of the definitions are. This is going to be a definition-heavy unit because of all of these terms. So the first thing we want to look at is just matter in general. What is it? Well, matter is anything that has mass and takes up space. It's pretty much everything around us. We call matter with a uniform and unchanging composition a substance or a pure substance, meaning it's only one thing. And we're going to be looking throughout the year at substances and what they're made of and how they interact with each other. So to review quickly the three states of matter: solid, liquid, gas. Solids are a form of matter that have their own definite shape and volume. Liquids take the shape of their container, but they have a definite volume. And gases have no definite shape or volume. They expand to fill their container. And we use the term vapor to refer to the gaseous state of a substance that's a solid or liquid at room temperature. Like we call water that has evaporated water vapor, we don't call it a gas because usually water is a liquid. So we have that special term for gases that started out as solids or liquids at room temperature. Now we're going to focus a lot on physical and chemical properties of certain substances. A physical property is a characteristic that can be observed or measured without changing the sample's composition. So things that have to do with what that stuff is, but it doesn't change what it's made out of. So color, what state it is at room temperature, its melting point, boiling point, density, all of those things are considered physical properties. And here you can see some examples of physical properties of some common substances. So we're going to be doing a lot of observations of properties. We're going to be measuring some properties and using properties of substances to separate them from other substances. A chemical property is the ability of a substance to combine with or change into one or more other substances. So this is the ability of something to react with something else. Like iron will react with oxygen to form rust. That's a chemical property of iron. Or copper will turn green when it oxidizes. So those things would be considered chemical properties. And when we're looking at these properties, substances can change their properties if their conditions are changed, meaning if they're not at room temperature or if they're not at normal pressure, some of their properties could be different. A lot of things have densities that change depending on pressure or temperature. Some things will react more or less at different temperatures and pressures. So when we're talking about physical and chemical properties, we need to specify what temperature and pressure we're referring to in that particular situation. Alright, now we're going to look at changing matter, physically and chemically. A physical change is a change that alters a substance without changing its composition. So phase changes are the most common example, where you're actually changing it from a solid to a liquid to a gas, but it's still the same substance. Boiling, freezing, melting, condensing, all of those things would be considered physical changes. You're not changing the substance, you're just changing what state it's in. Chemical changes involve the substances turning into new substances. So decomposing, rusting, exploding, burning, oxidizing, all of those mean something is reacting with something else and turning into a new substance. That's how you tell the difference between a physical change or a chemical change, is based on whether the final product is the same substance that it started out as. And we always have to remember the law of conservation of mass. It states that mass is neither created nor destroyed in a chemical reaction, it's conserved. And the same is true for physical changes as well. So the mass of the reactants is equal to the mass of the products. The mass before the change is equal to the mass after the change. And in an example, it says an experiment, we have 10 grams of red mercury 2 oxide powder. It's placed in an open flask and heated until it is converted to liquid mercury and oxygen gas. The liquid mercury has a mass of 9.26 grams. What is the mass of oxygen formed in the reaction? Well, according to the law of conservation of mass, If the reactants have a mass of 10 grams, the products have to have a mass of 10 grams. So to figure out how much is oxygen, we would have to subtract 9.26 from 10.00, and that would tell us that we have 0.74 grams of oxygen formed in the reaction. Okay, so far we've talked about pure substances. Now we want to look at what happens when we mix pure substances together. So a mixture is a combination of two or more pure substances in which each pure substance retains its individual chemical properties. So mixtures are physically mixed together. They are not chemically combined. They're not bonding with each other. They're just physically mixed together. And we have two different types of mixtures that we're going to be looking at. A homogeneous mixture is a mixture where the composition is constant throughout. We call those solutions. You can tell something is a homogeneous mixture because if you were to take a bunch of samples, all of those samples would be the same. You can't see the different parts. It's all completely uniform throughout the mixture. So salt water is a good example of that. A heterogeneous mixture is a mixture where the individual substances remain distinct. So I like to use a salad as an example of a heterogeneous mixture. When you take a bite of a salad, each bite it might be a little bit different. You can see the different parts. They're not all evenly distributed. That would be considered a heterogeneous mixture. And we're going to do two labs within this unit where we separate mixtures. And the first that we're going to look at is by filtration. And filtration is a technique that uses a porous barrier to separate a solid from a liquid in a heterogeneous mixture. So generally that porous barrier we use is going to be filter paper, and you're going to be separating out a solid from a liquid. So for example, if you make a precipitate, you could separate the solid precipitate from the rest of the solution. We will use distillation as a separation technique. So this one is for a homogeneous mixture of a bunch of liquids mixed together, and then the separation comes from their difference in boiling points. So as you heat up the mixture, the stuff with the lowest boiling point will evaporate first, so you'll be able to separate it from the rest. Crystallization is a separation technique for homogeneous mixtures that result in the formation of pure solid particles from a solution containing the dissolved substance. So, for example, if you have salt water and you evaporate all the water, the salt will crystallize and be separated from the water. So it's a way of separating things that are dissolved in water. Sublimation is a process of solid changing directly to gas. So think of dry ice. That's what dry ice does. It goes directly from solid to gas without going through the liquid phase. That's called sublimation. So if you have a mixture of solids and one sublimates and the other doesn't, you could separate them. Chromatography is a technique that we'll use later in the semester. And it's a way of separating the components based on the tendency of each to travel across the surface of another material. So what we're going to use it for is to separate different colored pigments in ink as they travel across paper. That's what we're going to use for chromatography. So we'll see some of those techniques in labs throughout this semester. All right, the last thing we need to look at is we need to take the idea of a substance and distinguish even further into elements versus compounds. So an element is a pure substance that cannot be separated into simpler substances by physical or chemical means. Elements are the smallest things. You can't break them down any further. They're the things that occur on the periodic table that have 1, 2, or 3 letter symbols. And we'll get more into how the periodic table is organized in a later unit. But just remember that elements, they're on the periodic table. Those are the only elements that we know of. And they are the they are the simplest forms of matter. And then a compound is made up of 2 or more elements combined chemically. That word there is the key term for a compound. You have elements that are chemically bonded together. They're not mixed like in a mixture. They are chemically bonded, which means they can be separated, but they have to be separated chemically. So in water, Water is a pure substance. It is a compound, but it contains hydrogen and oxygen, and those two elements can be separated from each other through chemical means. And generally, when you're separating compounds, you have to put in some kind of external energy, like heat or electricity. So, for example, if you want to separate the hydrogen and oxygen in water, you can't just heat it up. That just boils the water. You have to actually add electricity to it. And when electricity is added to water, the hydrogen and the oxygen will separate from each other, as you can see in this diagram. The law of definite proportions states that a compound is always composed of the same elements in the same proportion by mass, no matter how large or small the sample. So water is composed of 2 hydrogen to 1 oxygen. And when we talk about percent by mass, we're talking about the mass of the element divided by the mass of the compound times 100. Okay, so it's a ratio of mass. And if we look at this table, we can see sucrose is sugar. Okay, it's composed of carbon, hydrogen, and oxygen. And no matter how much of it we have, if we have 20 grams of sugar, this is the percent by mass, 42.20% carbon, 6.5% hydrogen, 51.3% oxygen. If we have 500 grams of sugar, we get the same percent by mass. So each substance, each compound, always has the same percent by mass, no matter how much of that compound we have, 20 grams or 500 grams. And the law of multiple proportions states that when different compounds are formed by a combination of the same elements, different masses of one element combine with the same relative mass of the other in whole number ratios. So you can have different compounds with the same element in them, like peroxide and water both have hydrogen and oxygen, but they're going to be in different ratios. The peroxide is in a 2:2 ratio, the water is in a 2:1 ratio. So they're going to have different percent by masses based on the ratio of elements in the compound. So here you can see an example of 2 copper compounds. In the first compound, copper is 64.2% by mass, 35.8% chlorine by mass. And in the second compound, copper is 47.27% by mass, and chlorine is 52.73%. So they're made out of the same elements, but they have different mass ratios. You can see here the copper to chlorine mass ratio is different. So that's the law of multiple proportions. All right, we're going to be using these notes on Thursday and Friday of this week, and then in the next 2 weeks as we're doing some of our labs with separating mixtures. So make sure you know these definitions, bring these notes to class, and we will use them in the activities that we're doing.